Okay, let's look at the application of the remainder theorem. So I'm going to use two questions from your textbook. This is out of exercise 1, and I'm going to do number 1E. And you will see how easy the application actually is. So exercise 1E. And the question states the following. It says, use the remainder theorem to determine the remainder when fx is divided by gx. And then they give you the following expression. Fx is equal to 2x squared plus 3x minus 4. So 2x squared plus 3x minus 4. And then they say gx is equal to 2x minus 1. Okay, so when fx is divided by gx, so we take the divisor, we make it equal to 0, and then you calculate x as a half. Now in fx, we just substitute in x's place a half. So 2 times a half squared plus 3 times a half minus 4. So let's calculate. A half square is a quarter, so it's 2 times 1 over 4 plus 3 times a half minus 4. So 2 divided by 4 is a half plus 3 over 2 minus 4. So a half plus 1 and a half is 2. 2 minus 4 is negative 2. And that's the remainder. That's it. That's the application. So let me just revise that again. This is the one type of question that I ask. So what calculate the remainder if fx is divided by gx? So you make the divisor 0 equal to 0, you calculate x, and then from there on you substitute that x into fx, which is a dividend, and then from there on, when you calculate it, it will give you the remainder. Now we're going to do number 3 from the same exercise, and they say the following. It is asked, when fx, and then they give you the expression for fx, is divided by x plus 2, the remainder is b. Determine a in terms of b. Okay, so this is number 3. So fx is equal to x cubed plus ax squared plus 5x plus 3. And they tell us that it's being divided by x plus 2, and then the remainder is b. So they're telling us the remainder is equal to b. So these two are important. Okay, let's look at our application now. Okay, so first things first is you take your divisor, you make it equal to 0. So that means x is equal to negative 2. Now in fx place, we know that if we substitute 2 in, it will be equal to the remainder. And the remainder in this case is given as b. So now we take our expression, which we had is x cubed, so it's negative 2 cubed, plus a times x squared, so it's negative 2 squared, plus 5 times x, and x is negative 2, plus 3. And this is equal to b. Okay, so negative 2 cubed is negative 8. That becomes a plus 4a minus 10 plus 3 equals b. And the question was to determine a in terms of b. So all of this has to go across. So we have 4a equals b. Okay, so negative 8, negative 10 is negative 18, plus 3 is negative 15, so it becomes a plus 15 on the other side. So a equals b plus 15 divided by 4. And that is one of the applications of the remainder theorem. They could have asked this question in various ways. They could have even asked it like this. They would say, okay, what if fx is divided by x plus 2 and it's equal to, and then they give us a value like 7 or something. Then they can ask us, calculate the value of a. Then we do exactly the same. You will still have the negative 2 there, a 7 where b is, and then a 7 over there. So the only unknown would have been a, and then you just solve for a. So there's many ways to ask this, but this is the basic principle that you need to follow.